Hi, I'm Chris Donahue. This is a follow-up video to an aquaponics system that my students created in early February of 2013. Originally, the first concept was just a simple deep water culture bed that's used in hydroponics that was fed from goldfish waste, pumped back up, and it grew one tomato plant. Well, since then, we expanded that project. That same class of juniors, now currently my seniors, designed and came up with two different systems, one being a raft system, which is this bed, and then a second system, which is just a straight medium-based bed with hydroponic pH-neutral clay rocks. In this system, we grow sprouts, we're doing some vegetative grass, and then in the second system, we do larger root-based items like tomatoes and cucumbers. Aquaponics is a combination of hydroponic and aquaculture. You get the best of both things, and then you do away with the negatives, like the excess fish waste, and then also all the chemicals needed to use in a hydroponic system. In this system, the fish waste acts as the food. Fish waste is ammonia, which is basically what most commercial fertilizers is ammonium nitrate. Well, in this system, biological filter positive bacteria break down that ammonia into nitrate and nitrite, which the plants are able to then absorb. The system continuously flows. It goes into a standpipe. The other system has a siphon that the students designed. It allows the water level to rise up to a certain area, and then it dumps that water just by using a PVC pipe, no motors required, and then it brings it back into the water tank, which oxygenates the fish tank, allowing the fish to survive. Aquaponics is very unique because you get all the concepts of horticulture, the plant horticulture science, greenhouse management, mixed into an enriched lesson involving science and math, and also reading and writing because of the research that it has to be done. We probably spent about 2 months designing this, and now each year I'm able to teach a 3 to 4 week lesson on aquaponics. The reason why aquaponics is not just a trend, a continuous feature, is this has actually been going on in other countries for thousands of years, and this concept is growing in popularity because of population bases, especially in urban areas where accessible land is not available because it's either taken up by blacktop or by buildings. This can be done in a small-scale system with one fish on your counter pumping up to, let's say, a 2-liter pop bottle. Next, I'm going to show you some of the components of the aquaponics system that the students designed. This is the biofilter. Two of my students, BP and Austin, will tell you more about this system.
Hi, I'm BP.
I'm Austin.
And we're from Glen Oak Horticulture. We created the swirl filter system out of 2 5-gallon buckets and a pipe. We have a pump in the water that brings the water up into the bucket, and it creates a swirl system, and the large particles come to the bottom. We're able to drain the large particles out with the system that we created, and the water goes back into that bucket, which Austin will tell you.
When the water fills up here, it spills over into this bucket, which is filled with filters, biochemical filters that empty out, that take out all the bad stuff and go out to the aquaponic system and give nutrients to the plants, and then it goes back down, drained into the fish tank, and then it gets to feed all over.
These are the Nile tilapia. They're all males. They grow larger in tanks than females. So in the industry, commercially, they use male Nile tilapia. There's also blue tilapia as a different species of tilapia. You can use those as well. This is the second system. As you can see, it's just filled with the medium. In this case, it's pH-neutral clay rocks. Here is buckwheat and ryegrass. And we also have butter crunch